Welcome everyone to today's Explainer. Today, we're going to decode the invisible rules that govern, well, absolutely everything we do online. We're zooming in on the transport layer of the OSI model. Now, that might sound super technical, but it's basically the universal framework for how computers talk to each other. The stakes here are massive. This layer dictates exactly how all data is transmitted over the internet. Without it, the web as we know it simply wouldn't exist. To really ground this abstract concept in reality, just think about your digital life for a second. Every single email you send, every streaming video you binge watch, every fast-paced online game you play, they all rely entirely on this fundamental delivery mechanism. Data doesn't just magically teleport from a server to your screen, right? It has to be packaged up, routed, and delivered according to incredibly strict rules. Okay, let's dive into this tale of two protocols. Here's our agenda. Number 1. The data delivery dilemma. 2. TCP, the reliable choice. 3. UDP, the speed demon. And finally 4. Choosing the right protocol. Section 1. The data delivery dilemma. Whenever data travels the web, it needs strict rules to get from point A to point B successfully, and developers basically have two distinct philosophies to choose from. Let's meet our very first contender. Section 2. TCP, the reliable choice. Highly structured and incredibly rule-driven. So, TCP stands for Transmission Control Protocol. This is a connection-oriented protocol, meaning it absolutely insists on establishing a formal, polite connection between the sender and the receiver before a single piece of actual data is exchanged. Think of TCP like a meticulous white-glove courier service. It mathematically guarantees that your data will be delivered without a single error, that all those data packets will arrive in the exact correct order, and if anything somehow gets lost along the way, TCP will automatically retransmit those lost packets. To pull off this flawless delivery, TCP uses a few heavy-duty mechanisms. First up is flow control. This prevents the sender from completely overwhelming the receiver by ensuring data is only sent at a manageable rate. Next is congestion control, which is essentially built-in algorithms that manage overall network traffic so the whole internet system doesn't bog down. And finally, acknowledgments. TCP demands receipts. It requires an explicit, firm acknowledgement from the receiver for every single piece of data to confirm it was successfully received. So the crucial point here is that TCP prioritizes reliability over speed. Because of all this overhead, the extra work of establishing connections, monitoring traffic, waiting for all those receipts, TCP is inherently slower. But hey, that is the price you pay for absolute perfect reliability. And when you really think about it, there are huge chunks of our digital lives where this data integrity is absolutely paramount. When you're loading a secure web page for your bank, you need every single byte of data perfectly in place. When you send a text-heavy, crucial work email, or you're transferring a massive, important file, you literally cannot afford to have data arrive out of order or just go missing. For these use cases, TCP is exactly what you want. But what if you don't care about perfect receipts? What if you just want raw speed? Section 3, UDP, the speed demon. Fast and connectionless. UDP stands for User Datagram Protocol. And in stark contrast to TCP, UDP is totally connectionless. No prior handshake, no polite introductions. UDP just gathers up the data and blasts it out onto the network without guaranteeing reliable delivery or ordered arrival. It is lightweight, it is lightning fast, and it's completely unapologetic. Think of it less like a courier and a lot more like a t-shirt cannon. The juxtaposition with TCP is just amazing. UDP entirely strips away all that heavy overhead. There's no built-in flow control, no built-in congestion control. It relies entirely on the receiving application to figure out how to handle the influx of data. As a result, data packets might get lost in the void or they might arrive totally out of order. Honestly, UDP doesn't care. Our source material actually describes UDP with this brilliant quote. It is a fire and forget protocol. Unlike TCP, UDP never, ever asks for an acknowledgement from the receiver. It just shoots the data over the network and immediately moves on to the next task. No receipts, no checking back. Because it completely lacks that heavy overhead of establishing connections, waiting for those acknowledgments, and checking for errors, UDP prioritizes speed and incredibly low latency above all else. It is wildly, ridiculously fast. This makes UDP the absolute undisputed king of real-time applications. Think about live video streaming, voice-over IP phone calls, fast-paced online multiplayer gaming, or instant Internet of Things IoT applications.
Look, in a live video stream, if a tiny data packet gets lost, you might see a single, slightly glitched pixel on your screen for a fraction of a second. In a fast-paced game, you might drop a single frame. That is a completely acceptable trade-off for experiencing zero lag in a live environment, right?
All right, moving into the home stretch. Section 4, choosing the right protocol. Let's catch our breath and bring things back down to earth for our final head-to-head showdown. Now, what's really interesting about this slide is how it perfectly summarizes the core philosophy clash of the entire internet. On one side, we have TCP, reliable, ordered, but slower. On the other side, UDP, unreliable, connectionless, but drastically faster. It is the ultimate battle of reliability versus speed. Let's walk through this cheat sheet together. The choice of which protocol to use depends entirely on the specific requirements of the service that's being developed. If you're building a web app, a file transfer client, or an email service where data integrity is paramount, you go with TCP. But if you're designing a live streaming platform, a voice calling app, or a super fast-paced game where low latency is way more critical than perfect reliability, you choose UDP. But here's a really fascinating twist that developers use in the real world. They don't actually have to choose just one. Many complex modern applications use a clever combination of both protocols simultaneously. They'll use TCP for the parts of the app that require secure, guaranteed text and data transfers, and then they'll use UDP for the live voice or video feeds running inside that exact same app. It's all about optimizing overall performance and reliability for different types of data under one roof. So as we wrap up this explainer, I want to leave you with a question to chew on. Think of the app you use the absolute most every single day. Based on everything we've learned about perfect reliability versus raw speed, is that app running TCP, UDP, or maybe a clever combination of both? Next time you send a message or start a live stream, you'll know exactly what's happening behind the scenes. Keep exploring, keep learning, and I'll see you in the next explainer.